We're going to continue our discussion on integration by learning about a new technique in this section called substitution. This is sometimes called U-sub for short. U-sub means the same as substitution. Now I want to let you know when you're doing these problems for me on your quiz submissions or on that last test, I do need to see all of your work with all of the steps for these problems so that I know you've got the right idea. What we need to do in general is take your function that is composed of another function. So we've got function composition going on, and we want to make the inside function our substituted u piece. So the inside part is going to be considered u. That's going to be what we consider your g of x. That's the inside expression. Du dx is g prime, or du equals g prime times dx. And then go back into your original problem, get rid of all of the information that has x's as part of it, and substitute everything with u's instead. So u is your variable that you're using to substitute for some particular piece of your problem. And you might not get it right the first time. You might try a substitution of something that's not going to work out. Don't be afraid to cross that out and start with a brand new attempt with a new type of substitution. At the very end of your answer, you're going to want to go back and put all of the appropriate substituted pieces back in terms of x. So this is what I'm talking about. For question number 1, think of this as e to a power. So e to a power, and this power doesn't just contain one term, not just a 5x. If it just had 5x, we would know what to do. If it just had a 3, we would know what to do. But it's 5x plus 3, so we need a new technique, and that's where u sub comes into play. So we're going to say let u equal the exponent, the 5x plus 3. Some big chunk of the problem needs to be your u. And so du dx, well, if I differentiate that equation with respect to x, I get 5. Du dx is 5. Or how about even better? Du equals 5 times dx. All right, just multiplying both sides by dx, you get there. So I'm going to take my problem and I'm going to write it as a bunch of stuff with u. E to the u is what the e to the 5x plus 3 becomes. Now, the dx, let me take this line right here and change it just a little bit. Dx would be equal to du divided by 5. And so what I'm getting at here is that in your problem, there is no such divided by 5 component, right? So what we're going to do is we need to figure out how to make my problem contain that piece, because that piece, once it pops up in your integrand, is going to be your du. So check out what I can do. I can put a 5 in that problem. Blow it up. Let me make this better. I can put a 5 right here. I can put a 5 here. But if I do that, I have to compensate by putting in a 1/5. See what I'm saying? So you can put in that constant in 5. You can put a constant in anywhere you want to. You couldn't do this with a variable. This only works with numbers. But if you're going to put in a constant of 5, a factor of 5, you need to compensate or balance it out by multiplying by 1/5. Because then all you did was you put in a constant of 1. Isn't 5 times 1/5 the same thing as 1? Yeah, so it's like you multiplied by 1, and that's okay to do. So you didn't change anything. You didn't do anything wrong. You just put in the piece that needed to be there. So here's what we're going to do. We're going to replace 5 dx with du, right? Don't forget, 5 dx. That's what du needs to be. And so I'm going to put my du here. And don't forget, you have a 1/5 here. Lots of things. I keep saying don't forget. There's so much you cannot forget. But once you do a few examples and you get into this routine, I think it'll become more natural. All right. So my du, right here, my du is 5 dx. Well, I've got the dx, but I didn't have the 5. I needed a 5, so I put the 5 in the place. I put it in there anywhere. You could have put it there where I have it. You could have put it here. You could have put it here. Wherever you want to, it does not matter as long as you got that 5 in there. But as soon as you put that 5 in there, you have to balance out by putting in a 1/5. And I like to put it in front of the integral just so that it doesn't get all jumbled up. Well, how do you integrate 1/5 e to the u? Well, that's just 1/5 e to the u, right? Plus c. Don't Forget that. And now you're almost done. You're going to replace that u with what it was equivalent to way back in the beginning when you had let u equal to. Well, instead of a u, it needs to be 5x plus 3 like it was in the beginning. That's it. All right, let's try another one. Number 2. Now I'm going to write this a little bit differently because I don't like it in the denominator like it is. I'm going to write this as 3x plus 5 to the negative 1 power. Okay, so you make your u statement. How do you want u to look? You want u to be something. Maybe a 3x. Maybe a 3x plus 5. You know, try something and see how far you can get. So let's try 3x plus 5. du is going to be 3, how about this, du dx is equal to 3, all right? So that means that du equals 3 dx. Well, I've got the dx, but I don't have the 3. It has to be by itself. It can't be the 3 that's with the x because that was already used. But I have to compensate now with a 1/3. So now the 3, the dx, that is right here. That's going to become your du, okay? That becomes your du. So now I have the problem that says 1/3 times the integral of u to the minus 1 du. Remember in the last section we learned that the integral of u to the minus 1, well, that's just the same thing as the integral of 1 over u. We learned that that was the natural log of u. So this is 1/3 times the natural log of u plus c. Now go back, replace the u with what it's supposed to be in terms of x. There you go. And that's done. And you could check by taking the derivative to make sure you got back to where you were at the beginning. Next one. All right, so at first glance you might say, well, I need to expand this out, don't I? I need to take x minus 1 to the 5th power, multiply it by itself 5 times. Well, that's kind of a lot of work. Yes, that would work, but it's a lot of work. So we're going to use u substitution instead to take this integral. Let's let u equal the quantity 3x, or sorry, just the quantity x minus 1. All right, so then du dx is equal to just 1. Or how about we say that du is equal to dx. This becomes my du. And everything else, the expression x minus 1, is going to be u. Well, this is going to be u to the 6th over 6 plus 3u cubed over 3 plus 5u plus c. How about we go back and put in what u was supposed to be? U is supposed to be x minus 1 to the 6th over 6. The 3's cancel out here. So this is x minus 1 cubed plus 5 times x minus 1 plus c. All right, here's one. We got to try to integrate this with respect to x. We're going to use u substitution for our technique because honestly, I don't know what to do with that, do you? There is no opposite of product rule when it comes to taking the antiderivative. So I need to come up with an appropriate substitution. I don't know. Let's let u equal the exponent, the x squared minus 1, that piece right there. And so derivative with respect to x is 2x. I could also write that as du equals 2x dx. So if I look in my problem, I have the dx and I also have the 2x. I have everything I need. All of that is what I need to change it to a du. Awesome. So that goes away and all becomes du. The highlighted parts all become du, which is great. The integral of e to the u is e to the u plus c. And then go back and replace the u with what it was equal to, x squared minus 1. All right, y'all, pause the video. You guys try number 5. Next video, you know what, just pause the video and try number 5 on your own. When you come back, it'll be filled in for you. All right, so you're back, right? You're back. You figured it out. Hopefully you got something that looks like that. So I let my u be the denominator, the x cubed plus 5 component without the square, just the inside piece. Do you see what I'm talking about when I talk about the inside function? It's what is being squared. It's the what part. And so that's the inside piece. That would be your, if you compose the function here, that would go inside that bottom part. And so du is equal to 3x squared dx. I skipped a step there. Hopefully you were able to see that. We needed a 3, didn't have a 3, so I put 1 in there, and I had to compensate with a 1/3 in the front of the integral. So 1/3 times 1 over u squared du is what this becomes, u to the minus 2. The integral is u to the minus 1 over minus 1, with the 1/3 in the front, making it a minus 1/3, and then go back and substitute what the u is supposed to be. Number 6, here we go. So I'm going to say that u should be x to the 4th minus x squared plus 6. How did I know that? Well, if it's not that, what else would it be? Maybe the top part? Okay. If it's the top part and you take the derivative, how's that going to work with your substitutions back in for u? Whereas if I let it be the piece that I written down and I take the derivative, I would get 4x cubed minus 2x dx. I could also think of this as something like that. And now it looks vaguely familiar with what that numerator looks like. Here's the numerator. I'm going to factor out a 5 from that numerator. And there it is. It's the exact same thing. Okay. All right. So my du needs to have a factor of a 2 along with that grouping of parentheses. My problem has a factor of 5. Well, instead of trying to get technical with dealing with that 5, how about you just put in a factor of 2 and then a 1/2 in the front? And then you don't have to worry about how to split that 5 and make it into a 2 and things like that. So your du is going to be the 2 and this expression and the dx, okay? And this is basically gone now because I just rewrote it. And the problem now becomes 1/2 times the integral of 5. Should have put the 5 in the front. Oh well. 5 over the square root of u du. Oh, what's that? Okay. So once again, I should have put the 5 in the front. Let's call it the 5/2. Integral of, instead of the 1 over the square root of u, how about u to the minus 1/2? Now take the integral and you got 5/2. U to the negative, nope, not negative, positive 1/2 over 1/2 plus c. And I'm going to write that as, let's see, 2 over 1 times 5 over 2, u to the 1/2 plus c. And those 2's cancel out. And now I have 5 u to the 1/2 plus c. And go back with the u and write that as 5 times x to the 4th minus x squared plus 6 to the 1/2 and plus c. Add that constant. That's the end. All right.